Welcome to qnawire.
Hi there. Here we have to answer a couple of questions about the roller coaster. So prior to the answer, let's calculate total energy of this mechanical energy of the system, which equals to the sum of the kinetic energy and potential energy. Or in other words, it's mass of the roller coaster multiplied by squared velocity divided by 2, which is kinetic energy plus mass multiplied by g multiplied by h, which is the potential energy. And due to the fact that there is no friction in the system, the total mechanic energy doesn't change. So this value is constant. Now we can answer the first question. We have to find the velocity at point A, right? Yeah. As we can see, h at point A, the height at point A of the roller coaster is the same as the initial one, which is h. Therefore, we can write down the mechanical energy for point A. So at point A, total mechanical energy equals to the mass multiplied by square root of velocity at point A divided by 2 plus mass multiplied by g multiplied by h at point A. It equals to the total kinetic energy, total mechanical energy of the system, which is mass multiplied by the initial velocity squared divided by 2 plus mass multiplied by g multiplied by the initial height. So as we can see, these two guys are the same. So therefore, the velocity at point A equals to the initial velocity, which is 17.0 meters per second. So now let's answer the next question, which is to find speed at point A. We have to find the velocity at point B when the height of the roller coaster is h/2. So let's calculate the total mechanical energy for point B. So it equals to m multiplied by squared velocity over 2 plus mass multiplied by g multiplied by h at point B. It equals to the total mechanical energy of the system. So now let's rearrange this equation. So we can get rid of the mass and divide this equation by 2. So it becomes the following. So the square of the velocity at point B equals to the square of the initial velocity plus gh, right? Therefore, the velocity at point B equals to the square root of the square the initial velocity plus gh. Let's calculate it. It equals to 17.0 meters per second squared plus 10 meters per second squared multiplied by 42.0 meters. So I need to use a calculator to complete the calculation. So it equals to 26.6 meters per second. So this is the answer to question B. The velocity equals to 26.6 meters per second. Let's answer the next question. Question C. So here we have to calculate the speed at point C when the height is 0. So therefore, at point C, the system will have only kinetic energy, which equals to the following, and it equals to the total kinetic energy, which we've already calculated. So therefore, again, we can get rid of the mass and multiply the equation by 2. So kinetic energy at, the velocity at point 2 becomes square root of the squared initial velocity plus 2gh. Let's calculate it. It equals to 17 meters per second squared plus 2 multiplied by 10 meters per second squared multiplied by 42.0 meters. So again, let's use a calculator to get the number. It equals to 33.6 meters per second. And the last question is regarding the maximum height. So when maximum height is reached, kinetic energy equals to 0. So therefore, velocity is 0. So then total mechanical energy of the system is only the potential energy, and it equals to the initial energy. So therefore, h maximum height equals to square the initial velocity divided by 2g plus the initial velocity plus the initial height. So which equals, and numerically, numerically it equals to the following. H equals to 42. So let's complete this calculation. So it equals to 56.5 meters. So the maximum height of the roller coaster boat is 56.5 meters, which is the answer to question D. So now let's summarize our results. So for question A, the answer is 17 meters per second. Then 26.6 meters per second. Then 33.6 meters per second. And the last answer is 56.5 meters. So now we've completed this question. I hope I helped you. Thank you very much.